Alright guys, today we are going to talk about logarithmic equations, okay? So if there are two different ways that you can take notes today, we're actually going to start back where we left off. So these are going to be the exact notes that we have in our notebooks. So if you are one of the people that actually have your notes with you, these are in your notebooks, so you're lucky if you are one of those people. If not, and you have access to a printer, these are actually going to be underneath Unit 7, so you can go to Unit 7, and, well, actually, you have to click on Unit 6 and then scroll down. So if you click on Unit 6 and then scroll down, this is going to be, let's see, logarithmic equations. So I will publish that so you all can see it, and it'll be 7-7. This is only if you have access to a printer. Now, if you don't have access to a printer, you do not have to print this out. That is perfectly okay. You can take these notes on a regular piece of paper, write down the problems, and that will be sufficient. This does not have to be this specific piece of paper. Okay, so as long as you're writing down the problems and the work that we do together, that is just as good as if you were to print this out. Okay, so don't stress if you don't have these exact notes. All right, so we are just going to do it exactly like we would do if we were in class. So looking at this one, you have two different types of logarithmic equations. The first one is if you have a log equal to a log. And this kind is actually the easy kind, as long as you have the same base. And in this, on number 1, we have log 5 and log 5. So if that's the case, then just like before, you drop the base. So remember that 5 is our base, then we would just drop that base and forget that it's there, and just write 5x plus 9 equals 6x. And then from there, you just solve like normal. So from here, I would get my x's together. So subtract 5x from both sides. I would be left with 9 equals, and 6 minus 5 is 1x. Now, the condition to these is that you have to check and make sure that they work. Okay? A big factor here, and we're going to put a star here, and I want to make sure that you write this in your notes, is that logs cannot be negative. Okay, so when you plug it back in and we say log 5 of 5, and we know that x is 9 plus 9, what we get inside this parentheses cannot be a negative number. And then equals log 5 of 6 times 9. This can't be negative either. And in this case, this is going to be 54. And this is going to be 54. So neither of those are negative, so we're good to go there. And I want you all to try number 2. It's the exact same as number 1. So when you solve number 2, you should get that n equals -7. Now, we still have to check and make sure, so when we plug in, we would get log base 2 of 1 minus 4 times -7 equals log base 2 of 2 times -7 plus 43. So 1 minus 4 times -7 is going to be 28 plus 1, so 29. And then 2 times -7 would be -14 plus 43 is 29 as well. So it's the same number, and they are both positive, so that one checks out as well. All right, on number 3, again, they have the same base, so we're good. We're just going to drop the base. So then we would have 6 minus 3w equals -2w. So then from there, I would get my like terms together and add 3w to both sides. then we'd have 6 equals negative 2 plus 3 is just W. So then you would get just 6. So then again from here, plug back in and check. Log of 9, I'd have 6 minus 3 times 6. And then log base 9 of negative 2 times 6. So 6 minus 3 times 6 is 6 minus 18, which would be negative 12. And then negative 2 times 6, again, is negative 12. Now, here's what I'm talking about. We cannot have a negative number here. Whatever the log equals cannot be negative. So since this is a negative number, 6 actually doesn't work. Our answer is actually no solution here. Okay, so you cannot get whatever the logarithm is cannot equal a negative number. And I want you all to try number 4. Now remember, this plus sign with our properties of logs means that we are going to be multiplying. So remember that key fact whenever you all try number 4. Alright, so whenever we solve, we would be multiplying the y plus 5 and the 4, so we would have to distribute that 4. So then when we solve everything, we would get y equals 13. Now we still have to plug in, so we would plug in a 13 right here, and 13 plus 5 is a positive number, so as long as that's a positive number, you know that it's going to be fine. We could also check it out as 13 plus 5 is 18, and then it would be 18 plus log of 4. So since it's plus, that means we're going to multiply. And is 18 times 4 72? Yes, it is. So then we are good. Our math checks out. Now on number 5, we have something multiplied out in front. Now whenever that happens and we have our properties, then that means it's going to be raised to the power. So now I have 4 to the third power equals 4a minus 8. And again, I can just get rid of that log base 7 because it's the same on both sides, so I don't even need to put it. So then 4 to the third is 64. 4a minus 8. Okay, I'm going to get like terms together, so I would add 8 on both sides. 64 plus 8 is 72. And then divide by 4. And 72 divided by 4 is 18. Okay, again, we need to check. There's nothing I can really plug in on the left side because it doesn't have any variables to plug in, so I need to just plug it in on the right side and make sure. So 4 times 18 minus 8. And then 4 times 18 minus 8 is 64, which we just said is the same thing as 4 cubed. So again, we know that that math checks out as well. So we're good there. I actually want you all to try number 6 as well. So whenever we have subtraction, then that means we're dividing. So you would have 68 divided by 4 equals 3n plus 11. So then when you solve, you should get 2. Now again, we only have a variable on the right side. So we need to plug in our answer, which is 2, n for n. So that would be 6 plus 11, which is 17. And we know that 68 divided by 4 is indeed 17. So our math, again, checks out. All right, on number 7. Again, we have a number out in front, which means we are raising it to the power. So that would be 25 to the 1/2 power equals 23 minus 4w. And again, I can only do this because they have the same base. So 25 to the 1/2 power is the same thing as the square root of 25, which I know is 5. Get my like terms together. So I would subtract that 23, and 5 minus 23 is negative 18, and I'm left with negative 4w. Divide by negative 4, and negative 18 divided by negative 4 isn't perfect, but I have two negatives, and I can divide both of them by 2. So 18 divided by 2 is 9, and 4 divided by 2 is 2. So this one's going to be a fraction. Now again, I need to plug in and make sure that everything ends up okay. So I don't have any variables on the left side, but I do have one on the right side. So I've got 23 minus 4, and then I'm going to plug in 9 over 2. So 4 times 9 is 36, and 36 divided by 2 is 18. Now 23 minus 18 is 5. And we know that the square root of 25 is also 5, so our math checks out. Alright, we are going to skip number 8 for now. We are going to go on to number 9. Now, number 9, if you will notice, has a square in it. So this is going to change things up just a little bit. Now, again, our bases are the same, so we're just going to forget that those bases are there. I would have m squared equals 18 minus 7m. Now, since it has an m squared, that means that this is going to be a quadratic. Remember, anytime you have a quadratic, you're going to want everything on one side to kind of see where you are and see what you have. So I'm going to have m squared. I'm going to move this 7m to the other side, which means I would make it a positive. I'm going to move the 18 to the other side, which means that would become a negative. Alright, so now I have a trinomial, because it has 3 terms. A, which is the term out in front, is 1, so that means I can just draw my x. I'm going to think of something that would multiply to negative 18. That would add to 7. Okay, and that's going to be 9 and negative 2. So then I would say m plus 9 and m minus 2. And since we're setting it equal, I need to set those equal to 0. So m plus 9 equals 0. That means m would be negative 9. And m minus 2 equals 0. That means m would be 2. So this time, since it's a quadratic, something squared, you're going to have 2 different answers. Now, of course, we still have to check this and make sure that we don't get any negative answers. So, for m, negative 9, I'm going to plug in negative 9 on both sides. So first I would have squared. So negative 9 squared equals 18 minus 7 times negative 9. So negative 9 squared is 81. And then 18 minus 7 times negative 9 is, again, 81. So that one checks out. Negative 9 is good. Then let's try 2. So I'd have 2 squared equals 18 minus 7 times 2. 2 squared is 4. 18 minus 7 times 2, that would be 14. 18 minus 14 is, again, 4. That one would check out. So on this one, we would have 2 answers, and that would be just as good. All right, you all try number 10. All right, guys, on this one, the plus sign means that we are multiplying 2 and k squared. So then it equals k squared plus 16. We would move everything to one side since it's a quadratic and get k squared minus 16. So then this one would be difference of squares. And then we would get k plus 4 and k minus 4 as our factors. Set them equal to 0 and get positive 4 and negative 4. Then when we plug in, we would get 32 on both sides, or actually on all sides, and it would check out and get all of our answers. So both of our answers check out.
I can learn to understand you much better.
Okay. So we are good.